Welcome all, welcome to this lecture of object-oriented programming. Today we will be continuing unit 4 and most probably we will be finishing this unit today itself. Let me start the session and let me show the disclaimer first for that. Okay, so let's start. Now in this unit what we have to see is lastly we had seen one very important thing, that was specifically the visibility modifiers, right? So let me take you more deeper into this visibility modifiers part. Okay, and let me show you one specific thing that I feel is very much important for you to know to understand the visibility modifiers. Okay, so see, basically we have public, private, protected, and the default visibility. Okay, so these three are specifically uh, used along with this names itself, whereas there is no name or there is no keyword for default. If you don't give any visibility modifier, then that is default visibility. That particular statement will have default visibility. So if I define a class let's say I define the age. So I don't define any visibility over here. So by default it is what? Default. Okay. Then suppose I make private, let's say hobby. That would be, let's say, private. So we specifically use the private keyword, right? Then if you want to use public, then we say public. That's a name, that's public. Okay. And let's say there is something protected. Okay, protected, and let's say height. Okay, now see, this class has got 4 variables and it has got different visibility scopes. One is default, another is private, another is public, and the last one is protected. Okay, so this has got 4 different scopes. Now how does this scope act? How is this visibility modifier affect this object? So check this out. Let's say this is class person, and there is a class called student. Student inherits from person class. Student inherits from the person class. Okay. So what happens is, which properties does the student get from the person class? The age property, name property, and the height property. Okay, the age, name, and height. It does not get this hobby property. Okay, So I'll just write over here. Here we have age, hobby, name, and height. Whereas in the students, which one do we have? In the student, we have age, then name, and then height. Okay. Now suppose there is another class, that extends this. Let's say college student. There is a class called as college student. Okay. And this college student class inherits from this. What inherits from this student class? So here, which properties would you get? Here you may get age property, okay, and name property. Do you see? This hobby was private, right? This hobby was private. So this private visibility modifier is limited to the class itself. Then we have this height, which is protected, right? We have this height which is protected. So that protected visibility modifier is limited up to the direct what? Up to the direct subclass. Up to the direct subclass. Okay. Even though that subclass is in another package, then also that would apply. Understand? And then this age and name appear over here. Now see, for this we have to understand the packages also. So this is one package. Okay. This is one package. Let's call it as package P1. Okay. And then we have another package P2. Then we have another package called P2. Okay. And in this P2 package, let's suppose that we have a faculty class. Okay, let's suppose we have a faculty class, and faculty class inherits this particular class. Okay, faculty class inherits the person class. Understand what I mean to say? Yes. So which properties would faculty class get? See, now this age is what? Age is having default scope, so it is limited to this package only, right? So this age will not appear over here. That will not appear. This hobby is private, so by default this is not going to appear. This name and height, name is public, so obviously name will appear over here. Faculty class will have a name property, and it can also have height property. Hence, faculty is a direct subclass of person class, even though it is in a different package. That doesn't mind. That is not a problem. Understand? So, direct subclasses get the protected property. Okay, and even though if they are in different packages, then also they get it. So you see, there is a different scope. There is a scope that has been defined now. Which is the limited scope? Very, very limited scope. Obviously, private is the most limited scope because it is limited up to the class only, right? Then the somewhat more, or we can say somewhat less restricted scope is the default scope. Why? Because the default scope is available inside the whole package. Okay, inside the whole package. But then there is somewhat restriction and less restriction also, like protected, where it says that it can be given to the direct subclass only, that may be in the same package or maybe in different package, because the default property was not accessible in different package. Understand? So we created protected, which allows a property to be accessed in a different package also. Okay, and the most, or we can say least restricted, is public. It can be accessed anywhere. So this name is the public property, so it is inherited over here also, even over here also, right? Understand? So now if we have, let's say, a class like visiting faculty. Okay, what properties would this have? Tell me. This would have obviously the name property that faculty is having, and this height will not be there. This height will not be there because this is not a direct subclass of this person class. So it cannot access that protected property. It's as simple as that. But if you want to make all this available in this class also, in this class also, in this class also, and in this class also, then what should we do? Tell me. Yes, what should we do in order to access these in any of the classes? So the best option is to define the getter methods, getters and setters. Best option is to define what? The getters and setters, or the getter and setter methods for these properties. And these getter and setters are normally what? These getters and setters are normally having public visibility modifier. So using getters and setter, you can get the name, you can get the height, you can get the hobby and age, and you can even set it. You can even set it. Understand? So that thing is possible. But this direct access is not possible. For example, this height is not accessible to this because height is protected, and protected scope is limited to the direct subclass that may be in same package or maybe in different package. Default scope is limited to the current package. Private is limited to the current class, and public is unlimited. It is unlimited. Okay, understand? Okay. Okay. So I hope you people have understood. There are various books available on Java certifications. If you refer that, you will find that there is a specific table made. That table is comparing various scopes. So that would be very easy for you to understand. You can refer those books which are specifically for certifications. Okay. Okay, so this thing was remaining, and what else I found is, okay, we have seen static variables, right, and static methods also. Let's see static constants. How do we define static constants? Okay, let me show an example for that. Okay, let me again present my screen. Let me show you one example that I have made. So we will use this particular static demo example, and let me make a new class here called as static demo dot java. Okay, in this, okay, check this out. This is a very good example that we have made, and so this particular example focuses on static variables. Okay, so it has got, this class is static by name. This class is called static by name. It has got two variables a and b, which are static variables, and these are two integer static variables, and it also has a boolean static variable. Okay, now then there is this test method. Okay, there is this test method, and then there is this static method also, call me. Okay, and here in this class static demo, we are using the static by name. So check this out. Here in the static by name, one thing is that basically, see, this is a static by name class where we have three static variables and one instance method. Okay, these are what? These are static, or we can simply say class variables. Okay, and then we have this as what? This is instance method belonging to the instance or can be called by instance only. And this is what again a static or class method. Okay, so now see, this test is an instance method, so it can access the static variables also and static method also. We know that the instance to static access is possible. We know that instance to static access is possible, but the reverse is not possible. Okay, this thing is possible, but the reverse is not possible. So you cannot use this test call. Check this out. You cannot call this test over here. Okay, because this test is what? This test is an instance method. Okay, so that's why we have commented it out. And you can access the static variables directly, no issue in that. And in this instance method, you can call the static method also. That is also fine. Static method can be referenced from a non-static context, and it can even access static variables. Okay, and then we try to create an object of the static by name class. We call a static method, and we over here directly access the static variables also, you see. And we even try to call the static method through the instance. That is also possible, that is allowed. Okay, that is allowed. Now let me add a constant to this. It says that how do we make constants? Constants are made using final keyword. So I say static final and id equal to some value. So now what happens? Okay, I have to define the type also. So now what happens is this id is the what? This id is the variable that is of type data type int, having value 999, and it is final, so it cannot be changed at all by anyone. Okay, and it is static, so it is accessible through class name. So you can access it over here. You can simply say system.out.println and what? Static by name dot id. You can access it like this. Understand? Okay, so let me show you how we can use this final part, right? Let me give one very small example of static. Okay, so let's do one thing. Let's do one thing. Let's create a final variable in such a way that it gets the number of the number of the specifically the instance number that has been created. Okay, so this, let me show you. This is a very good idea that I've got. Let me just implement it over here. Okay, and we'll have a class. Okay, this is a public class. Let's make this public, and we will have a class saying object counter. Okay, this is object counter class. In object counter class, we have a static final object number value, which is of type int, or it may be, let it be int only. Okay, so we have static final object number, right? What is the error? It may not have been initialized, right? So okay, let's say we'll say object int, instead of object number we can give object type id. Okay, and now in this object counter, constructor, we define it. Object id is this is that. Okay. Okay, so this would give us error. Is it giving the error? Yes. So now see here, once we assign this 0, we cannot assign it any number to it. So here we have to assign some value. Okay, here we have to assign some value to it. Okay, and once we define it, then we cannot assign it any value. Okay, so what we can do is we can use this type id to be assigned to specific let's say, let's call this as type id 1, and then type id 2. Okay, and then we have again type id 3. Okay, so we have object type id 1, 2, and 3. Okay, and in object counter we say object. Now let's, what we will do is we'll have an object type int type. Okay, and along with that we also have static int total objects count. We have total objects count. Okay, now here what we will do is we will say that in this object counter, let's not make use of this simple object counter, no argument constructor. Let's make use of a parameterized constructor. Okay, let's make use of a parameterized constructor. And in this parameterized constructor, we will provide some value to it. Okay, or what we can do is we can increment this total objects count, and that can be assigned to the id int object number. Okay, so this total object count can be assigned to this object number. Okay, each time total object count increments, that new incremented value is given to the object number, and this total objects counts is the shared variable for all the objects. Okay, so for each and every object gets a new object number. Okay, and we can decide that if here we can decide if the object number is divisible by, let's say if we want to define two types. Okay, one is for even numbers and another is for odd numbers. Okay, so one is this one, another is two. Okay, so let's say we want to define the object types. Okay, so we can say instead of type ID we can say object even, and here we say object odd. Okay, so now we say if object number is divisible by 2, which is equal to 0, if that is the case, then what do you do is that you assign the type of this object equal to what? Object even. You see? Else you assign the type to be what? To be object odd. So now what you have done is you have used this constant variables to assign the values to an instance variable. We have used the constant variable to assign its values to an instance variable called as type. Okay, so these three things define the type. This one is the total number of object counts. This is the object number itself. Okay, so now once we have created an object, the total number of count will also increase. The new number will be given to that particular object, and if that object number is an even number, then it will go into type object even, otherwise it will go into type object, sorry, odd, not even. Here we say what? Object odd. Okay, now let's just check it out. We make an object counter object. Okay, this object counter OC1 is equal to new object counter, right? In the same way, we define various objects. Okay, now if you want to print how many total objects are there, okay, if you print that total number of objects created, how would we print that value? From where will we get it? From this static variable total objects count. So we say total number of objects created are object counter dot total objects count. Okay, in this way we get the total number of objects. And if we see the ID of each and every object, okay, OC1 ID, how do we see that? OC1 ID is equal to what? OC1 dot object number. Okay, object number is the number that has been given to that particular object, and each will be a different number because it is getting incremented each time. Check this out. Okay, now let me run this out. You saw that, guys? Yes, you saw that. In this output, this is static variable, and these are what? This is the static variable, and these are specifically the what? These are specifically the instance variables. Okay, these are the instance variables. You see? So static variable is shared between all the, and that you can see once it is shared, once as soon as it increments, the new object is created, it is incremented. So before it was 0, first object created, it became 1, and we assigned that 1 to this OC1 ID. Then it became 2, then it became 3, then it became 4. In this way, we make use of the static variables. And also, now we have also made use of the static constants, right? So we can simply what? Let's make a toString method over here. Public string toString method. This is the best way to represent your object. Okay. So here what we'll do, here we will return a string. So we say string str is equal to, first we will say what is the object ID. Okay. So we'll say object ID plus what we will add to this is object number. Okay, that is the object, or we can simply say object number is this, and then we say let's add some more space to it. Let's concat some space to it, and here we say what, that specifically here we say object number is this, and now if we check, if the type is equal to object E1, okay, type is equal to object E1, then we simply say str is equal to str plus, we will attach a string to it saying that it's an E1 type of object. E1 object, we'll just say E1 object. Okay, and we attach it like this. It's an E1 object. Okay, and then here we put else. Okay, and here we add odd object. Okay, so let's see what happens. Let's see what it prints. Okay, so it has to return, right? So here we say return str. Now instead of doing all this printing thing, what we'll do is we'll simply print this OC1. We'll simply print this OC1 into the println statement. That's it. And every time we just simply change OC2, 3, and 4. Let's see now how it displays. Check this out. You can see over here object number and object type. You see, this is a meaningful output. In this way, you might want to categorize your objects and want to display that that object is belonging to this particular group or some other group. Then you can usually make use of such logic based on the constant. These constants are also defined in the same class. Okay, these constants are also defined in the same class. If you see this code, if you see the code, then the constants are defined in the same class, so no one can change it. So you can define, you can declare a well-defined constants which no one can change. Okay, and then you can assign a variable to a a variable can be assigned a value with uh, this constant values, So this way, and now you can even make it private. This int type can be made as private, so no one can access it outside. No one can access it out. So this is a totally secure code, we can say, that we have defined the types for identifying the objects that are okay. That also we can make it as private. Okay, this also can be made as private, okay, so that it's not accessible outside. As simple as that. Understand? And this object number can also be made as this total object count should not be made private, but this can be made private. Okay, static total object counts can also be made private. It should also be made private because nobody should be able to access it outside the class. Okay, if a constant is there, we can make it public. Let's make this constants public. Constants can be public, no issue in that, because nobody is going to change it. But this total object counts is an instance variable, so some code can change it, right? So that's why we are making it private. This object number should also be made as private, right? Whereas this final variables do not need to be made private. For if it's for internal use, then if you make it private, that's fine. Otherwise, you don't need to make it private because nobody will be able to change this. Understand? Since it's final. So in this way, now our code has become totally secure. Okay, nobody can play with your code without the way you want to. Okay, that's what I hope you understand this logic. This logic does what? It defines some constants. Depending on this constants, it provides the type of that particular object, and also uses a static variable to define the number and also total number of objects. So each object gets a unique number, okay, when it's created, and when then you run it out, you are using this toString method to describe that particular object. Okay, now here what is it saying? It's saying, okay, total object counts is not visible. Okay, that we have made as may. This has been made as private, that's why it is not visible. Okay, so what we can do is we can make a method public get total objects count, as simple as that, and there we return this total objects count. Here we put it as what? It returns what? Integer type, right? And here we'll simply call this method. That's it. Get total objects count. And this is not an okay. So now it needs to be a static. It needs to be a static method. Okay. So it's a public static. So now we can access it by class name. That's it. So now it is accessible. If we run this, the program runs very well, easily. You see that? Okay. Let me see if you have any doubt. Okay. So I can see there are no doubts. Any doubt in this topic, please do let me know. Yes, because this is quite difficult for many people to understand how static works, how it behaves, and what is the actual purpose of making use of static constants and all those things. I just showed you a logic where we can make use of static constant so that we can make our code secure, and we can make a specific we can implement a logic which is helpful in some identifying the identifying the objects and all. Okay, so I think I'll stop the recording. If you have any doubt, you can ask me.